Hey there everyone! Welcome to the first episode of our image processing with Python series. If you have ever wondered how those jaw-dropping filters on Instagram work or how your phone magically recognizes your face, then you are in the right place. In this series, we are diving into the world of image processing using the power of Python. We will start from the basics and work our way up to some seriously cool stuff. So grab your coffee, get comfy, and let's start. Hit that subscribe button and ring the bell so you don't miss out any of the fun. Alright, let's get this party started with our virtual environment setup. First things first, we need to create a virtual playground where all our image processing will happen. This keeps our project nice and tidy. Here's how we do it. This command sets up a new environment named imagepn. Now let's activate the environment. Boom! You are now inside your new virtual space. It's like stepping into a fresh, new coding world. Now we need to install the essentials. Here we are loading up our toolkit with some of the best Python packages for image processing. Think of it as packing your bag with all the must-have gear for an epic adventure. Let's talk about what images actually are. Whenever we work with images in a programming language, we are really just dealing with multidimensional numerical arrays. So if you are already familiar with 2D lists or numpy and D arrays, guess what? You are already halfway to understanding what an image is. Let's keep it simple and start with a grayscale image. Imagine zooming in super close and you will see that the image is made up of tiny dots called pixels. Each pixel is the smallest element of an image and has its own intensity. Put a bunch of these pixels together and voila, you have got your final image. Each pixel's intensity is represented by a numerical value. There are different ways to map these values, but a common method is to say the highest intensity is 255 and the lowest is 0. So you can picture it like this. The brighter the pixel, the higher the number. In a grayscale image, it's just a simple matrix with rows and columns where each entry represents the intensity of a specific pixel. And that's why, in reality, an image is simply a numerical multidimensional array. Cool, right? When it comes to image processing in Python, there is a whole treasure chest of packages out there waiting for you. Some of the heavy hitters include OpenCV, scikit-image, and Pillow. Now, I know it can feel a bit overwhelming at first, but don't worry, we have got this. Each package comes with its own set of superpowers. The key idea behind all these packages is that they let us read images into Python as numerical multidimensional arrays. Once we have that, we can start applying all sorts of cool image processing techniques. Throughout this series, we will explore the unique features of these packages and see how they stack up against each other. By the end, you will know exactly when to use each one to make your images look amazing. Let's kick things off by importing the essential packages we will need. Matplotlib for displaying images right inside our notebook. Numpy, the go-to package for numerical operations in Python. Scikit-image or skimage, a super handy package for reading, writing and processing images. Order-dict, help us keep our summary stats nice and organized. Now let's create a cool little function that gives us some quick stats about our image. This will come in handy later on. Think of this as your images report card. It tells you the mean, max, median, mean and quartile values. Neat, right? Time to load up our image. We are using skimage to read the image as a grayscale. Why grayscale? It's simpler to start with, and then we will move on to color images. Here we set the path to our image and use sgray true to read it in a grayscale. Let's define a helper function using matplotlib. This will help us easily show images in a stylish manner throughout our notebook. Now let's put our helper function to the test and display our grayscale image in all its glory. Here we go. And voila, here is our image. Cool, right? Before we dive deeper, let's take a closer look at the image object to understand its properties. This will give us a better idea of what we are working with. When you run this code, you will see image shape is telling us the dimensions of the image, and the first value is the height and the second one is the width. Type of image object. You will see that image is an object of the numpy array class. As you can see, this means that our image is simply a numerical array in Python. This is super powerful because it allows us to perform all kinds of numerical operations that are possible with numpy arrays. Now that we know our image is a numpy array, we can use slicing to get specific parts of the image, for example. Let's give it a try. In this command, we are slicing the image to get just the rows with indexes from 1350 to 1449 and columns from 825 to 924. Essentially, we are zooming in on a specific part of the image. To better understand slicing, visualize the image as a grid of pixels where the top left corner is the origin, 0, 0, rows are indexed vertically and columns are indexed horizontally. When you slice, you are selecting a smaller rectangular section of the image. Here is a visual guide to help you understand the axis directions. So the x-axis corresponds to the rows of the image and y-axis corresponds to the columns of the image. Now let's take a closer look at the actual values of our sliced array. As I mentioned earlier, there are different ways to represent the intensity of each pixel by numerical values. In this case, we have a float image, meaning that the intensity of each pixel is represented by a float number in the range from 0 to 1. Here 0 corresponds to black and 1 corresponds to white. Let's summarize the values of our image array to get a better understanding of the intensity distribution. This will give us a detailed summary of the minimum, maximum and quantile values, providing a comprehensive overview of our image's pixel intensity. What if we want to change some values in our array? Let's reassign a portion of our image to black. By doing this, we are setting the selected portion of our image to 0, making it completely black. Check out how this modification looks. We can switch between different ways of representing pixel values in the image, for example using the image as ubyte function from the skimage package. With this change, the summary will show that black corresponds to 0 and white 255. This transformation is essential for various image processing tasks. We can also perform operations like stacking images using numpy. Let's stack our image side by side. This demonstrates the flexibility and power of numpy in handling image data. The key point here is that images are simply numerical arrays. You can apply all kinds of methods that you know for numerical arrays and matrices to images. That's it for today. Next time we will explore colored images and different ways of representing colors on a computer. Thank you for sticking with me until the end. I appreciate your interest in learning about image processing. If you enjoyed this, join my Telegram channel where I post more thoughts related to programming. You can find the link in the pinned comment. Take care, my friend. See you next time.